call dimensional analysis. How do we convert number from one subunit to another? We will get into details of that in the next learning objective. But first, we want you to be able to look at a particular measurement and be able to determine how many sig figs we're going to keep. How do we do rounding? Okay? And since you're doing measurements in laboratory there, you are going to be dealing with sig figs. So pay attention to the basic rules that governing the handling of the sig figs here. So that's going to be the focus of the fourth learning objective. Now, what is significant figure? Now, sig fig, the digit in a measured quantity that reflect the accuracy of a measurement. That's what we call the sig fig. That's a definition. I may not necessarily ask you how to define, ask you the definition of the sig fig, but you need to know what is a sig fig. Sig fig has something to do with a measured quantity. Okay, we also call it significant digits there. Remember, it's a measured quantity. Now the question, you must observe, or when you do scientific measurements here, you must observe and use correct sig fig in all calculations. In this course, or in other courses there, physics class that you'll be taking, other chemistry class you'll be taking, whatever calculation that you're doing there, you have to make sure you have the correct number of sig fig. So this is very important. How important? I'll repeat. It's very important. You have to pay attention to sig fig. Okay? And in addition to that, you also need to pay attention to the units there. Okay? So here's a question there. Sig fig, as we define sig fig, is a measured quantity. We ask you how many students are in this classroom here, and you count, do a head count there, you come up with 48. So this is an exact number. Now, exact number has no, we don't use the term sig fig on the exact number. Okay, so we can ask you how many sig fig in there? Well, we say exact number has unlimited number of sig, because this is not a measured quantity. We have 48 people in this room. That's an exact number. Okay. Now, one thing about the exact number there, we will be introducing what we call conversion factors. Conversion factors are being treated as exact numbers. We know that 1 gallon equals to 3.785 liter. Now, 3.785 liter, and that's 4 digits in there. How many sig fig? Well, we don't use the term sig fig. That's not a measured quantity, it's a conversion factor. So remember, exact number has unlimited number of sig fig, or we simply don't use the term sig fig on exact number. And we treat conversion factors, that's a very important thing. Conversion factors are something that we will, introduce a little bit later today. Conversion factors are treated as exact numbers. So you don't use sig fig on the exact number there, and it will not limit the number of digits in your calculation if it involves a conversion factor in the calculation there. Okay, so what is a measured quantity? Here's an example. If you put water in a graduate cylinder, okay, and a closer look on the volume of water there, it goes from 15 to 20. Okay, each line represents a milliliter there. Now, these are the measured quantities there. We know the volume in this water, in this graduate cylinder is 15, 16, 17. Well, it's more than 17. Not quite 18 yet. So we can read the volume accurately based on the measuring equipment here to the number right before the decimal. Okay. We know it's more than 17, but not 18. So what's going to be the measured quantity here? Well, the first decimal place, or the only decimal place you can guess, well, it's going to be an estimate here. So it's between 17 and 18, somewhere around halfway through. So 17.5. Can you do 17.56, 58? Well, there is no certainty beyond the first decimal point, beyond the first decimal place. Okay, so you can't get to the second decimal place in this particular reading. And here you can estimate the first decimal place in this particular. Now, if you have another device like a burette that we use in analytical work when we do titration there will be 10 small lines between each milliliter. Now you can accurately read to the first decimal place, decimal place there. If the meniscus, the curved bottom of the liquid, rests in between 2 small lines there, you can estimate a second decimal place. So in a sense, a burette is more accurate than the graduate cylinder. compared to this register one. Because this one you can only read to the first decimal place, the burette you can read to the second decimal place. And the more decimal place you get, the more accurate the equipment is. Remember, the measured quantity, well, sig fig is an indication of the accuracy of the measuring equipment. So this is something that we do want you to pay attention to. Now, how do we determine the sig figs? And how do we handle the sig figs that we obtain from the measurement there? There are certain rules. How do you count which digit is significant, which one is not? Okay. These are the rules that I need you to, that word, the M word, memorize. So you need to remember these rules when you handle sig figs. First of all, when you have a measured quantity, all non-zero numbers are significant. Assuming this is a measured quantity, 123, you have 3 sig figs. 1234, you have 4 sig figs. 123,450, you have 6 sig figs. So all non-zero numbers are significant. You have to count them. Okay. Sometimes we ask you to determine the number of sig figs, and that's where this rule comes in there. Whenever you have a measured quantity, whenever you see a non-zero number, it's significant. You have to count them in. Okay. And rule number 2, zeros in the middle of number, significant. Okay. So 12,304. How many sig figs do we have here? 5. We have 5 sig figs. So the zero in between two non-zero numbers, that's significant. Okay, so that's rule number 2. And rule number 3, zeros at the beginning of a number are not significant. So this number, 0.01234. There are 6 digits in there. How many sig figs?
4.
Just 4. How about the next number?
4.
4. So the leading zeros are never significant. That's another thing you need to remember. Very important. Now these are the things when you look at lab number 2 in your lab manual there, we repeat these rules again, and you need to make sure that when you're taking notes in the lecture there, pay attention to these things. When you read lab number 2, hopefully before Thursday, before tomorrow when you go to the lab there, make sure you pay attention to those rules that we put in the lab manual there as well. Rule number 4, zeros at the end of a number after an explicit decimal point are significant. The word explicit is missing. So if you have 123.400, how many sig figs do we have here?
6.
6. Okay. You are looking for the decimal point here. If you do have a decimal point in the number there, these 2 zeros, what it means here is that you are using an equipment, doing this measurement, you can actually get to the 3rd decimal place. The 2nd and 3rd decimal place happens to be 0. You have to put them in there. It could be 1, could be 2. It could be other non-zero numbers. So this indicates the particular equipment that you use to obtain this particular measurement. You can actually go to the 3rd decimal place. That's why those 2 zeros are significant. So if you see an explicit decimal point there, you have to count those zeros in. Okay? And so in this number here, an example in this number here, we have 6 sig figs. Okay? Now, 0 at the end of a number before an implied decimal point may or may not be significant. So this is where things start to get murky. When you look at this number there, 123,000. Now, we know